We're going to finish Chapter 16 by looking at respiratory volumes and airflow. Spirometry can be used to measure the amount of air you're breathing in and out. Spiro means breathing and metry means to measure. This is all computerized now, but they used to use these tubes that you would breathe in and out through this air that's trapped in this bell jar. And then as you breathed in and out, the pen would then record on the paper the volume of air that you were breathing in and out. Make sure you know the lung volumes for the test and also know the abbreviations. So let's take a look at a graph and we'll go through what each of these lung volumes are. This graph is really important to know for the exam. I may put a graph like this on the exam and ask you, for example, to tell me what the expiratory reserve volume is. And so you'd have to read that off and say, well, that's 1,000 mils. So let's start with the tidal volume. The tidal volume is the amount of air that you breathe in and out with one breath at rest. So for most people, the tidal volume is 500 mils. The inspiratory reserve volume is when you're at rest and you breathe in, at the end of inhalation, you all of a sudden take as big a breath in as you can. That's the inspiratory reserve volume. The expiratory reserve volume is just the opposite, that as you're sitting there at rest and you exhale, at the end of exhaling, you take as big a breath out as you can, and that's the expiratory reserve volume. The residual volume is the amount of air left in the lungs after maximal exhalation. So notice that there's always some air left in the lungs. It does not go down to zero. And that's because if the lungs were completely empty of air, they would be collapsed. Lung capacities are when you add two or more lung volumes together. So make sure you know these. These are also important. I could ask you to read one of these on a graph as well. So let's take a look at these. Let's take a look at the inspiratory capacity first. So as you're sitting there at rest, just breathing in and out, at the end of exhalation, you take as big a breath in as you can. So the inspiratory capacity is we're going to add the tidal volume together plus the inspiratory reserve volume. So that would be the inspiratory capacity. The vital capacity is as you're sitting there at rest at the end of exhalation, you take as big a breath in as you can, and then you exhale as much as you can. So that's the vital capacity. And then the functional residual capacity is how much air is left in the lungs at the end of the tidal volume. So you're just sitting there at rest, breathing in and out, and at the end of exhalation, how much air is left in the lungs. That's your functional residual capacity. And then the total lung capacity is just how much air total could the lungs hold at one time. So remember we talked about asthma and COPD. These are the major obstructive pulmonary diseases. They have increased airway resistance. And if you increase the resistance, you're going to decrease the airflow. It's going to be harder to inhale and exhale. And because it's harder to exhale, the lungs become overinflated because you can't get as much air out as you should. So if we start over here on the left, A is normal. So we've got no increase in resistance in the airways in A. But as we work our way over to C, in C we've got a much higher resistance in the airway. So maybe this person's having an asthma attack. So you can see the tidal volume has stayed the same, but the inspiratory capacity, that biggest breath that you can take in from when you last exhaled your tidal volume, that has decreased because you've got an increased resistance here. You can't inhale as much air, so your inspiratory capacity will be decreased. And also your expiratory reserve volume is also decreased. So remember, that's when you're just sitting there at rest and you exhale, and then when you get to the end of that tidal exhalation, you take as big a breath out as you can. So notice that you're not going to be able to breathe out as much air as you normally could when you're having an asthma attack because of the increased resistance. And notice that the residual volume, the amount of air left in the lungs after maximum exhalation, has increased. So you can see that the lungs will become overinflated. So you can see the dotted line, which would be where the alveoli would be normally, but with the increased resistance, you can't exhale as much air, and so more air stays in the alveoli and the lungs end up being overinflated. To diagnose one of these obstructive pulmonary diseases like asthma or COPD, you can do a test called the forced expiratory volume. So they're going to have you take as big a breath in as you can and exhale as much as you can as fast as you can. So you should be able to exhale 80% of your vital capacity in 1 second. And if it's less than 80%, that means that you have increased resistance and you're going to be diagnosed with one of these obstructive pulmonary diseases, so either asthma or COPD. And then the last thing to talk about is the anatomical dead space. So if we're just sitting there at rest, breathing in and out, and we have a tidal volume of 500 mils, only 350 mils are actually going to reach the alveoli. The other 150 mils fills up the conducting zone. Remember, that's from the larynx down to the terminal bronchioles, and there's no gas exchange going on in there. So that's your anatomical dead space, would be that 150 mils. So let's take a look at what happens with the effect of the anatomical dead space on ventilation. So let's start down here on C. And the orange air is the old air. So we've already done our gas exchange, the oxygen is left, entered the blood, and we've taken the carbon dioxide from the blood and put it into the alveoli. So when you exhale, there's going to be 150 mils of this old air that's going to remain in the conducting zone. And then when you take your next breath in and have the fresh blue air coming in, unfortunately, the old stale air is going to be forced into the alveoli first. So this air that's in the alveoli is not going to be pure fresh air. 150 mils of it will be old stale air. So we can do a couple of calculations to figure out how much air is entering and leaving the respiratory system per minute. So this is the minute ventilation. So to figure out the minute ventilation, we're just going to take the tidal volume, which maybe is 500 mils per breath, and then we're going to multiply that by the respiratory rate, which maybe is 12 breaths per minute. So the minute ventilation would be 6,000 mils per minute, and that's the total amount of air entering and leaving the respiratory system each minute. But oftentimes we're much more interested in the alveolar ventilation because this is telling us how much fresh air is actually reaching the alveoli. So we just need to subtract from the tidal volume the dead space volume. So if the tidal volume was 500 mils and the dead space volume was 150 mils, we just subtract that, multiply that by the respiratory rate, and we can see that our alveolar ventilation, we only have 4,200 mils of fresh air reaching the alveoli per minute.